So this is example 1 of finding the area between two curves. This is about as friendly as one of these problems can get because I'm using polynomials, because I gave you the picture, and because I gave you the bounds. So in this situation, I'm finding the shaded area, which starts when x is 0 and ends when x is 2. Right? So I'm integrating from 0 to 2, and I'm going to do the top curve, which in this picture is f of x equals x squared plus 1. I apologize for my terrible graphing and also my messy handwriting. Over the bottom curve, which happens to be g of x equals x, right? So when I set up this integral to find this area, what I want to do is I want to integrate from the first bound, which is 0, to the second bound, which is 2, of the top curve, which is f of x, minus the bottom curve, which is g of x. Now, on an AP problem, if the AP calls them f and g, you can also regurgitate that notation, and you should. What you should not do is you should not invent a notation. So if they didn't call them f and g, if they just called this one y equals x squared plus 1, and they called this one y equals x, you can't call them y and y in your problem. You're going to have to write the entire function out. So I'm going to go ahead and write them out anyway, because I'm going to need to integrate. If it's a calculator section, you'll still need to write them out, but you can type them into a calculator to make them integrate, and we'll do some calculator skills in another video. So I can reorder this if I want. I don't see a real need to. So when I do the antiderivative, I'm going to get an x cubed over 3 plus an x minus an x squared over 2, and I'm going to be plugging in a 0 and a 2, right? So my area is going to end up being 8 thirds plus 2 minus 4 halves, right? All minus a whole bunch of 0. Don't just ignore the zeros, because every once in a while you have something, sorry, that's a 0 squared over 2. Every once in a while you have something that when you plug in, it doesn't come out to be 0. So for instance, cosine of 0 is a 1, or e to the 0 is a 1. So just be mindful that sometimes there's a trick. Turns out here that this nets to a whole bunch of 0, so I don't really care. But this ends up being an 8 thirds plus a 2 minus a 2. Oh, look how convenient. I don't even need a common denominator. My 2's cancel out, and I get that this area is 8 thirds. Now, you can confirm it in your calculator, and it's not a bad skill set to practice anyway. If I were going to confirm this in my calculator, I would put my y1 in as x squared plus 1, and I'd put my y2 in as x. I would then press math 9, which is function integrate, and I'm going to integrate y1, my top function, minus my y2 with respect to x from 0 to 2. And we can type that in real quick right now, and I apologize I cut you off a little bit on the video. But if we type this in the calculator right now, and I'm not sure how easy it'll be to see the calculator with this lighting, but we're going to try. So if I type into my y1, oh, there's a bunch of stuff in there. I'm going to type in an x squared plus 1, and in my y2, I'm going to go ahead and type in an x, right? And I'm going to quit out of there, right? So I quit out. So I'm going to go to math 9. Now, I have my calculator in this math type, and the reason I have it in this math type mode, or like the standard type mode rather, sorry, classic, not math print or whatever they call it, is because if you end up having to borrow a calculator on the AP and it's in the old school classic mode and you don't know how to use it, you're in trouble because it's not super intuitive. If you see that it is in the math print version that looks like an actual integral and has spots for bounds, then it's not so stressful. So I show you this way so that in case you happen to have a calculator that doesn't do it the fancy way, you're not in trouble. So, I'm going to go to vars. I'm going to go over to yvars function 1, right? So that's y1 minus vars over to yvars function and y2. Comma is this button, comma is this button directly above the 7, right? So there's above the 7. And then with respect to x, right? So that's with respect to x, comma from 0, comma to 2, and we're going to see if this works because I can't really see it all that well. I'm going to hit enter. Yep, and I get 2.6 repeating, which if you hit math, right, if you hit math and then pick frac, it'll turn it to 8 thirds and confirm that I'm right. So it's not a bad idea to make sure that you know how to do this on a calculator, even for the easy ones that are not calculator problems.